Hello and welcome to the live webcast Drown Attack, Threat and Vulnerability Update, brought to you by Venafi, the immune system for the internet. My name is Gavin Hill, Director of Threat Intelligence. Today I'm joined by Mark Sanders, one of our senior sales engineers at Venafi. Before we get started, I wanted to walk through a couple of housekeeping items. First of all, acknowledge that we've left some time at the end of this webinar to ask any questions in real time. So please do feel free to submit any questions via the chat window, and we'll circle back at the end. Also acknowledge that this webinar is being recorded and will be made available as on demand on venafi.com. So what we wanted to get started with today is really talk through the impact and vulnerability of the Drown vulnerability that was released actually last week at RSA. Also go through an action plan of the response and remediation that most organizations should be going through. In fact, any organization that suspects or that is utilizing solutions that do take advantage of or have still got SSL version 2 enabled are vulnerable to the Drown attack. So they should be looking at how to remediate that. Then what we want to do is also talk through reporting on that remediation, and then also what is really the competitive advantage that some of our customers have as a result of following through with the remediation steps that Venafi provides within our solutions. So with that, just as a quick overview of what exactly is the Drown attack. It's an OpenSSL vulnerability that enables an attacker to perform a man-in-the-middle attack on any TLS connection, and really they're able to effectively perform that in less than a minute. The way it does that is it sends probes to specific systems that still do support SSL v2, enabling then the attacker to perform that man-in-the-middle attack by ultimately recompiling, in essence, the private key. One thing to note, though, is the attack does not allow the malicious actor to actually capture the private key, but it does allow the malicious actor to perform a man-in-the-middle attack. As you see there on the screen, it impacts any SSL or TLS enabled service. And as far as from an impacted protocol perspective, even if you're using TLS 1.2 on systems, but you're sharing that same private key that's being used on those systems with other systems or utilizing that private key on other systems that still have SSL v2 enabled, you're vulnerable to Drown attack. So from an exposure and severity perspective, the probability is certain. In fact, you can take advantage of the Drown attack for less than $500 utilizing AWS services to perform the Drown attack. From a severity perspective, it's quite significant because of the ease at which you can perform the attack, and because there's still so many systems out there that do support SSL v2. The remediation approach is quite simple. Apply the relevant patch, so upgrade to the most recent version of OpenSSL that does address the Drown attack, disable SSL v2, and generate new private key, and then obtain a new certificate for that respective private key. So let's talk a little bit about the Drown attack then, and from an impacted systems perspective, a couple of different use cases. One of those, as you see here, even if a server is utilizing, say, a TLS 1.2 connection, or a user is using a TLS 1.2 connection, an attacker can still perform Drown attack by abusing the fact that that server still has SSL v2 enabled. In another scenario where, for example, in this illustration, a server again is utilizing TLS 1.2, and let's say for argument's sake that particular server does not have SSL v2 enabled, but another server does have SSL v2 enabled, and it's utilizing the same certificate, the same private key as the respective server at which the attacker is performing the attack on that specific session. In this case, the attacker can still take advantage of Drown, take advantage of SSL v2 still being enabled on the other server that is sharing that same private key on the respective session that they're trying to perform a man-in-the-middle attack on and take advantage of and sniff the traffic. So how many organizations are actually vulnerable, or what's the impact? If you look at even the Drown attack webpage, the authors do go into detail on how many vulnerable web servers out there are, and as you see from the scan that they performed, worldwide there's about 33% HTTPS servers that are vulnerable to this Drown attack. The thing that I think is more concerning, though, is, excuse me, the unknown risk, and that is really similar to that scenario that I talked through, that second scenario of all those systems that are sharing the same private key that are still or still have SSL v2 enabled. So think about it. Email servers, embedded systems, or web applications, or even software that all utilize SSL or TLS and take advantage of SSL or excuse me, that enable or allow SSL v2 on those systems, but still take advantage of the same private key on otherwise patched systems. Those otherwise patched systems are still vulnerable because of the sharing of that private key across systems. And this is where it becomes very important to be able to gain visibility into where all of those servers are, where those private keys and certificates are as well, and be able to replace them and remediate. So as far as a Drown remediation plan is concerned, first and foremost, it's important to upgrade to the most current version of OpenSSL that does address the Drown attack vulnerability. Also disable SSL version 2, generate new keys, issue new certificates, install and verify those keys and certificates have been replaced, and then revoke all of the old ones. Now, when you look at that from a Drown remediation perspective, the reason it's important to regenerate those new keys is going back to that original point I had, in that you need to be able to identify all of the systems that have SSL v2 enabled, and you need to definitively say that those systems are not necessarily using the same private keys as other impacted systems. If you can't definitively say that, you need to be able to replace all of those keys and certificates on any system really that is SSL v2 enabled. So one thing that's important to note here, it's almost like deja vu. If you look back at Heartbleed a couple of years ago, many organizations made a critical mistake. And the thing to keep in mind here is that you shouldn't make the same mistake that most organizations made when remediating Heartbleed. And that mistake really is, if you look at the Heartbleed remediation plan, is that a lot of organizations didn't go about regenerating new keys and certificates, validating that they've been changed, and revoking the old certificates. In fact, if you look at this Heartbleed remediation plan, it looks really similar to that of the Drown attack. You have to patch the OpenSSL vulnerability. In this case, you have to upgrade, well, first identify those systems and then upgrade to OpenSSL that had the no heartbeats flag on impacted systems, and then of course go ahead and regenerate new keys and certificates, because those keys and certificates, going back to Heartbleed, were captured, could have been captured without any trace. Drown is very much same from a remediation plan. So don't make the same mistake as most organizations made with Heartbleed. Last year, what we did is we did an evaluation on the global 5,000 organizations across a number of different regions. And what we found was most had not remediated Heartbleed. Most had made that critical mistake of simply patching and not replacing the actual private keys and certificates on impacted systems. Don't make the same mistake as Heartbleed. Make sure that you do go ahead and replace those respective keys and certificates. So From a Venafi recommendation to customers, first and foremost, as you would have seen, is patch for Drown, disable SSL v2, and then utilizing TrustAuthority, go ahead and create new keys that are in compliance with policy as defined within TrustAuthority, generate new CSRs, and then use TrustForce to replace those keys and certificates on servers, and then TrustAuthority to monitor the environment for any further anomalies. Mark's actually going to go through in a little bit more detail how customers can go about performing these actions within our solutions. So with that, if you do want to find out more, go to venafi.com drown attack, where we do have some additional information in a threat brief, as well as some steps and impacts related to Drown. With that, I'd like to hand over to Mark. Mark?
Thanks, Gavin. Good afternoon, everyone. So what we'll do next is we'll go a little bit more details on how Venafi can help. So there's actually there's two modules within Venafi. We have the TrustAuthority module and the TrustForce module, and they build upon one another. And so if you look at the steps that are necessary to remediate, so the very first thing we need to do is identify where SSL v2 is enabled, and our TrustAuthority module has that capability. So we tell you what protocols are enabled, so we'll tell you if you've got SSL v2, if you have TLS, and if you have a combination for, like a lot of systems, they have both TLS and they still have SSL v2 enabled, so we will show you those systems. Certainly the next step is to patch those systems, or quite frankly, disable SSL v2 if you need to patch to get up to TLS. That's outside of Venafi scope, so you need to patch. And then what happens, you come back into Venafi with our TrustAuthority module. We have the ability to generate new keys and new certificates, and we do that in an automated manner. With TrustAuthority, the final step is the ability to distribute those new keys and certificates to the owners. Now, with TrustAuthority, TrustAuthority will hand that certificate to that user. They can download it from a portal, and then that user would then install that new key and new certificate. If you have our TrustForce module, you'll see that we have the ability to automatically install those keys and certificates for the owners. So it really takes the human element out of that. And if you remove the human element, then certainly it's less error-prone, but then it's much more automated. You can scale to remediating thousands of servers in a very, very short period of time. We then want to revoke those old certificates, and you can do that with our TrustAuthority module. And then what happens is TrustAuthority, as it in the very step one, it identified where you had SSL v2 enabled. We're now going to validate again that SSL v2 is disabled, and we're going to validate that the new keys and certificates have been replaced. And you can do that regardless of either TrustAuthority pushed the new key and certificate to the user, or if TrustForce pushed it all the way, then we validate that process is complete. And then finally, we're going to do validation ongoing if we find the anomalies, if we see anything that pops up. For example, what happens if we were looking at the certificates that are still on v2 systems, and perhaps one of those systems was offline. So if anything comes online, it's still got v2 enabled, we find that and we notify someone, then we can remediate that. All right, so the next set of screens, we have some screenshots to show you exactly how this happens. So this particular UI is showing you, this is a user logged into the portal, and they're seeing exactly their hosts and certificates and systems that have v2 enabled. And so on this one, we privated out the IP address and host names of this particular host. But you'll notice that this has SSL v3, TLS 1.0, 1.1, and 1.2 enabled. So, and we tell you that we've done chain validation, SSL, TLS validation is complete. But this particular host does not have SSL v2 enabled. But you can see right there in the middle where the protocol is, and so it shows you exactly those systems that are vulnerable to SSL v2. The next slide actually shows what we call our policy view. And so with policy view, what it does is it specifies, you'll notice right there in the middle where it says CSR handling, CSR generation, service generated CSR. It's configurable whether Venafi is going to generate the CSR or if the user is going to generate the CSR. So there are scenarios where the user wants to generate their own key material and their own CSR, or you can have Venafi do that. It is flexible, but in this particular instance, you'll notice that Venafi is going to generate the CSR, so it's really automated from the user's perspective, making it very, very easy for our users to remediate Drown. And then on this particular slide, notice how we're saying that in the middle there, reuse private key is no. We do not want to use that same private key because perhaps that has been compromised. And so we're specifying here that Venafi is going to generate the CSR, and we are not going to use reuse the private key. And that policy is applied whether we generate the key material or if the user generates their own key material. And then there's workflows involved as well. So, what certificate authority we're going to use, what's the renewal window. So there's a lot of settings, and you can lock these things down at the policy level, once again, making it so that we enforce the policies and making it very, very simple for the user to do their tasks of, specifically remediating drown problems. And so here we've blown up the middle section about the private key. You'll notice that it says private key stored is yes, but we're not going to reuse the private key, and our key strength is a 2048-bit key. All right, this particular screen, there's the ability to do, certainly there's the ability to do one by one, renewals. But what happens if we have 1,000 systems, or even more? What if we have 2,000 or 3,000 systems that need to be remediated? We, obviously do not want to do that on a, one by one manual basis. So the particular UI that you're looking at here, we've given 3 options on how to do this operation in the bulk manner. So we can specify the new keys are going to be generated, the certificate's going to be requested from the certificate authority, and then we have the ability to either manual distribution of the key and certificate to the user for them to install, or, once again, if you want to have Venafi do the installation, then we can do it in an automated manner. And let me point out real quickly here is you don't have to do one or the other. You can specify to say some of my hosts, let's say that you have a load balancer team, for example, and they want to install the key and certificate themselves. But I may have my web server team, and they want Venafi to do it in an automated manner. So you can have it mix and match that way. You don't have to do completely one or the other. All right, so the image in the foreground here is when a user says, I want to download my key and certificate, we ask them what format they want that in. So that takes the whole process of just giving it to them in one particular format and then making your user do some sort of reformatting to get it in the format they need. We actually will allow them to download it in the format they want. And you'll also notice that we ask them, do you want to include the private key? Do you want to include the root? And then we will enforce a password. So, for example, if they get a PKCS12, we're going to ask them, do you want to include the private key? Do you want to include the root chain? And then we'll ask them for the password that will be embedded into that P12 file. And so it makes it really simple for our users to install. And then with TrustForce, same sort of thing, right? It's that same UI, but instead of it, us giving the key and certificate to the user, we're actually going to install it for them in an automated manner. And so we can do this on load balancers, SSL visibility appliances, next generation firewalls, web servers. We have the ability to install these keys and certificates into a very large number of systems. Right, and then there's also the notion of what we call the association model. So let's say, for example, and this kind of is an example of how one of the things that's kind of with Drown is that if you don't know where you have hosts that are sharing keys and sharing certificates, then that gets you into a potential blind area. And so what Venafi does is, there's absolutely good examples of where you need to have a single certificate, single key installed in multiple applications. For example, a application server cluster, for example, or maybe I have a load balancer, and behind that is a web server, application server. I may want to have that same key and certificate installed on both those hosts. Venafi accomplishes that through what we call the associations model. And so we say that I understand that this single certificate is installed in these 3 locations, and then when it comes time for renewal of the certificate or to install the certificate, we know where to place that single certificate into those 3 locations. And then we also tell you the status of that as well. So you can see that the status is okay, so we move through that workflow process. And then we have the remediation report. This is the view that gives you the information to let you know that the new key and certificate has been installed on the host. So you'll notice, starting from left to right, we'll tell you when the certificate's valid from, valid to, are we storing the private key, what's the distinguished name of where that particular host resides, what's the common name, what's the status. And so we give you the information about that certificate key so that we do know that a new key and new certificate has been generated and has been successfully pushed down to that host. And then we also have a escalation or a notification system within our platform as well. So when we check to see that if a new key and certificate has been successfully installed, we call that part of the validation process. If the validation process fails so that we know that that new key and certificate did not successfully get placed on that host, we throw up a failure event, and we will notify someone about that. The notifications can be something as simple as sending someone an email, sending a group email, but we also have the ability to open up ticketing system. You open up a ticket within a ticketing system, And so if you want us to send something to Remedy or something to ServiceNow, we have the ability to do that very, very easily. And it's not just a really stupid message that says, hey, something failed. We actually embed rich metadata into that so that you know exactly what system, get very, very detailed information about what exactly has failed. All right, Gavin, back to you.
Great. Thanks, Mark. So really, some final considerations that you need to think about is it's more than just patching. So like I mentioned, Heartbleed, if you think about other vulnerabilities, Freak and Shell Shock, Drown just shows the real importance of you have to absolutely first patch, as Mark went through, but it doesn't really stop there. You have to go then and look at where else where you're potentially vulnerable and replace those respective keys and certificates. So just like you would, if you presumed or expected that or had or you suspected that you had been breached and that as a result some passwords were compromised or accounts were compromised, you would go ahead and you'd replace all of your passwords. Similar fashion, if you think that you've been breached, or if you think that, or you know that systems are susceptible to this attack, and you don't really have any way of proving that any of that information has been captured, rather be safe than sorry and go ahead and replace those specific keys and certificates as well. The other thing is with Venafi, you're protected. So from a competitive differentiation perspective, Venafi customers, as Mark showed you, are really already able to identify which systems are impacted or vulnerable by looking at the actual certificates there and looking where those certificates are, and if those certificates are being used, for example, on SSL v2 enabled systems. And it enables also organizations to start taking action by replacing those respective keys and certificates on those impacted systems. And you're not alone. Any system or any solution utilizing SSL version 2 is susceptible to this attack. So with that, if you'd like to find out more, go to venafi.com/drown attack. I think what we're going to do now is open it up to a couple of questions. And I do see in the chat window, there's a few questions that have come in. One here, I think, Mark, would you mind taking this question? It goes, if TLS 1.2 is being used on my server, am I safe?
Got it. It's a good question. So if you're using TLS, are you safe? Yes, but you have to make sure that SSL v2 is disabled. But that's kind of a trick question, right? Because the thing that you have to be careful of is you have to make sure that the key that's used on that TLS server is not the same key that's been used on an SSL v2 enabled server. So is it safe? Yes, but as long as it wasn't shared on an SSL v2 enabled server, you're good. I got a question on this last week at RSA. Sort of a similar question was, this particular person I was talking to said that when they started reviewing this, they saw a lot of mention, whereas if they, the technical write-ups around Drown mentioned a lot about TLS and SSH v2, and SSL v2, and they couldn't quite figure out where the line between them drew. What the whole thing is the TLS connections is where kind of it all starts, right? Because what they're doing is they're looking for the RSA key exchange method. And so with that information, you then get that key exchange, and then you can take that over to the SSL v2, and that's where the intercept starts to happen. But if you're just using TLS, you're good to go. It's where you have TLS and SSL v2 or using the same keys, that's where you get into problems.
Great, thanks, Mark. And I actually think this is a related question, which I think I'll go ahead and address. And it goes, do we need to replace private keys on all servers? And I think, you know, the response there is similar to that of Mark's, that if you suspect that you have SSL v2 enabled on systems within your organization, and you don't know where they necessarily are, so you can't definitively say that you don't have SSL v2 on systems throughout your organization, you should definitely replace the private key on systems that you have patched that are now, for example, to Mark's point, using TLS 1.2, but SSL v2 has been disabled on those systems. You should absolutely, just to be safe, replace the private key and the respective certificate on those systems, because you don't know. In fact, working with the Ponemon Institute, most organizations, almost 55% of organizations don't actually know or have visibility into where all of their keys and certificates are. So as a result, they don't necessarily have visibility into where all of their SSL v2 or where SSL v2 is being used throughout their organization. So for those, which really goes back to Mark's point, if you're reusing that private key between systems that are not SSL v2 enabled and systems that are SSL v2 enabled, you should absolutely replace your private key and your certificates on those systems that are not SSL v2 enabled, because you don't know where else that private key is being used within your organization, like most organizations, according to the Ponemon Institute. I don't see any additional questions here. As I mentioned, if you do want to find out more information, please go to venafi.com/drown attack, and we'll do our best to address any of your questions there. As I mentioned, there is additional information there. There's a threat brief, as well as how Venafi helps to address the drown attack and respond to the drown attack for organizations utilizing our platform. Mark, thank you for your time today.
Thank you, Gavin. Thanks, everyone.
Thank you. Bye.
Bye.
Cut, Dustin.